Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.69. While solving this problem, we will be using current divider rule. Basic equations for the calculation of current I1 and current I2 of this particular circuit using current divider rule is provided here. We also will be using Ohm's law. According to Ohm's law, voltage across any resistance R is always equal to the product of current through that resistance and the value of resistance. Now move towards the problem. Exercise problem number 2.69. Find voltage VAB and VDC in given below figure. This is the circuit diagram of given problem. We have to find voltage VAB between these 2 points and VDC between these 2 points. So without wasting time, let's proceed towards the solution. For the calculation of voltage VAB and VDC, we should have voltage across these resistive elements. Right now we don't have the value of voltage across these resistive elements. So first of all, we will try to find out voltage across these elements. Later on, we will be able to calculate voltage VAB and VDC. And for the calculation of voltage across these resistive elements, we should have the value of current through these resistive elements. In only that case, we will be able to calculate voltage across these elements. So first of all, we will try to find out current through these resistive elements. Later on, we will be able to calculate voltage across these resistive elements. For the calculation of current, we will simplify this network. These two resistances and these three resistances are connected in series connection. So we can find their equivalent resistances and replace these resistances with their equivalent resistances. Sum of these two resistances will be 8 ohm. Similarly, sum of 4 ohm, 2 ohm and 2 ohm will also be 8 ohm. So in this circuit we can replace these two resistances and these three resistances with 8 ohm resistances. Now these two resistances are connected in parallel connection and both have same value. So we will find their equivalent resistance by dividing the resistance of a single resistance with the number of resistances connected in parallel connection. R equivalent will be equal to 8 divided by 2. Value of a single resistance is 8 ohm and number of same resistances connected in parallel connection is 2. So the value of equivalent resistance of these two resistances will be 4 ohm. We can replace these two resistances with a single resistance having the value of 4 ohm. Now the circuit is converted into a simple series network. We can calculate current through this network. Current I will be equal to voltage divided by total resistance of the network. In this case, voltage is 20 volt and total resistance of the network is 5 ohm. I will be equal to 20 divided by 5. So the value of current I will be 4 ampere. And the direction of this current will be counterclockwise. We have calculated the current with its direction in this voltage source and this 1 ohm resistance. Now we will move back to original circuit with this calculated current. 4 ampere current is flowing through this 1 ohm resistance and this voltage source in upward direction. Now we know the current of this branch. With the help of current divider rule, we can calculate the currents of these branches as well. For that purpose, this current will act as total supplied current and this current is entering on this node and distributing among these two branches. So before applying current divider rule, first we have to label these two branches currents. This branch current will be labeled as I1 and this branch current will be labeled as I2. Now apply current divider rule to calculate current I1. For the calculation of current I1, this equation will be followed. In this equation, I1 is equal to R2 divided by R1 plus R2 multiplied by I into T. I into T is total supplied current. In our case, it is 4 ampere. R2 is the resistance of opposite branch and value of R2 will be the sum of 3 ohm and 5 ohm. R1 is the resistance of same branch. In this case, the resistance of same branch will be 2 plus 4 plus 2. It will be equal to 8 ohm. Place values inside this equation. R2 is 8 ohm, sum of 5 and 3 ohm. R1 is also 8 ohm, sum of 2, 4 and 2 ohm. And total supplied current is 4 ampere. Take the product of 4 and 8. It will become 32 divided by the sum of 8 and 8. It will become 16. Now divide 32 with 16. The value of current I1 will be 2 ampere. We have calculated the value of current I1. Now the current I2 can also be obtained by using Kirchoff's current law. 4 ampere current is entering on this node and 2 ampere current is leaving from this node. So the equation for the calculation of current I2 will be I2 is equal to 4 ampere total current minus leaving current I1. Value of I1 is 2 ampere that we have previously calculated. So the value of I2 will be 4 ampere minus 2 ampere, that will become 2 ampere. On this node 4 ampere current is entering and it is distributing equally in these two branches. Direction of this branch current will be clockwise and this branch current will be counterclockwise. So according to the direction of current through these branches, we will assume the polarity of voltage across these resistive elements using passive sign convention theory. According to passive sign convention theory, current entering terminals are taken with positive sign and current leaving terminals are taken with negative sign. In this branch, current direction is counterclockwise, so current entering terminal is taken with positive sign and current leaving terminal is taken with negative sign. Similar case with this branch, current entering terminal is positive and current leaving terminal is negative. We will calculate voltage across only those resistances that are engaged in the value of VAB and VDC. Voltage of these two resistances will not be calculated. Direction of current in this 1 ohm resistance is upward. Current entering terminal will be taken with positive sign and current leaving terminal will be taken with negative sign. And the direction of current in this 2 ohm resistance is counterclockwise. Current entering terminal will be taken with positive sign and current leaving terminal will be taken with negative sign. Now using Ohm's law, we will calculate voltage across these resistances. Voltage across this 2 ohm resistance will be the product of current through it and the value of resistance itself. Current through this resistance is 2 ampere and the value of resistance is 2 ohm. So voltage across this 2 ohm resistance will be 4 volt. Next is the voltage across this 2 ohm resistance. Same voltage will be appearing across this 2 ohm resistance because current is same and the value of resistance is also same. Now voltage across this 5 ohm resistance will be calculated. Current through this 5 ohm resistance is 2 ampere and the value of resistance is 5 ohm. So voltage across this 5 ohm resistance will be 10 volt. Last one is the voltage across this 1 ohm resistance. Current through this 1 ohm resistance is 4 ampere and the value of resistance is 1 ohm. So voltage across this 4 ohm resistance will be 4 volt. We have calculated voltage across these resistive elements. Now we are able to calculate voltage VAB and VDC. First of all, we will calculate voltage VAB. For that purpose, we will assume the direction of current inside this branch is counterclockwise. Equation of VAB will be minus 4 volt plus 10 volt. Current entering terminals are taken. Subtract 4 volt from 10 volt. The value of VAB will be 6 volt. Now the value of VDC will be equal to minus 4 volt and minus 4 volt. In this case, the direction of current is assumed clockwise direction. So the sum of minus 4 and minus 4 will become minus 8 volt. So the value of VAB inside this network is 6 volt and VDC is minus 8 volt. So this was exercise problem number 2.69. Thank you. See you again in next video.